Most buildings in New Zealand are unique. They have their own individual characteristics, and we're able to design a fire detection system that suits the needs of the building. With the equipment that we provide, you can actually look at the condition of each detector from the control unit. Whereas if you had to go around and manually test 6,500 smoke detectors, it would be an absolute nightmare.
The basic process works pretty much like a screen print process. So the solder paste gets applied through a screen onto the PCB. This machine is currently placing the components, the surface mount components, so it places on that paste. These are all run off what we call Gerber files, which is the design file. So the R&D team will design the boards, the layout, what components go where. Next part of the process is the oven. So this is where the actual soldering is done now. Any components that's now been placed by hand, we need to now put some flux onto it. So again, we can activate the flux and then we can solder it. So this machine allows the flux to be applied by spray. It then goes over a heated element which brings all the boards and the components up to temperature, and it activates the flux. This one can't go through the conventional wave. Without gluing those components on it, they'll all be taken off by the wave process. So we've got to come and solder all these joints. With our products, because it's life safety, every single PCB that we manufacture has to be tested. Some of those actually get tested more than once as it goes through different phases of production. This has got all our PCBs on that we've manufactured based on what we think our usage is going to be like for the next week to 2 weeks. This board is going to end up going into a call point. There's actually 9 call points on one of these PCBs.
The board that we were looking at before, in fact, ends up in this product. Every time the little LED there flashes, this manual call point has actually been set a command from the fire department to say, hey, is everything okay? So if we broke the glass, plastic in this case actually, and operated the switch, the fire panel will then say, hey, someone has operated this manual call point, the evacuation signal will be given and the brigade will be called.
We get an order in from a customer. We then go and pick all the bits from our Kanban shelf, so all the boards, the master boards, loop driver boards, all the bits gets collected. They'll then assemble the gear plate, run all the wiring, loom it up, and fit everything together. We want to make sure that everything's wired like it should, so we want to make sure that there's not a higher voltage getting to something that shouldn't have.
Overall, we've got some 26 people in R&D department. Most of them are in embedded software, where we're writing applications or code for circuit boards that look after the fire alarm systems.
Obviously do our very, very best to ensure that the product goes out bug-free. So we spend a lot of time doing bug fixes, which is just part of the normal R&D process. No one on the planet can ever write error-free code straight up. It is a matter of continuous innovation, and if you don't do that, then other people will ultimately pass you.